A tool that has gained popularity over the last decade is the lever handle manual turret style flaring tool. This tool has been private labeled by more than a dozen vendors. Capable of doing SAE double flares, single flares, and DIN bubble flares. The tool is easy to assemble. The dies that come with the set are easy to use, and one of their best features is that the tube channels are smooth and do not chew up or mar the tubing behind the flare. The flare punches mount on a turret. The split dies come in sizes for popular tubing. The turret is removable, and flare punches can be easily replaced when worn. The chassis of this tool mimics expensive and precise European tools. At considerably less cost, this tool has lasted a decade with moderate use. Proper tube preparation is the first step in making any flare. This wise investment is a rigid 15 SI roller bearing tubing cutter. This tool will cut stainless steel tubing. The only feature that is lacking is a notch for the flare. Less expensive tubing cutters are available that have a notch that enables removing just the flare head from the tubing. For cutting fresh coiled tubing that has been straightened, this roller cutter works very well. The cut tubing end requires deburring to restore the inside diameter and set a chamfer at the outside. The standard SAE tubing is 3/16 inch with 28 thousandths wall thickness. The inline tube tool shown here is for deburring with 45-degree angles at the inside and outside of the brake tubing. With the inside diameter restored and a 45-degree chamfer at the outer edge, the flare end will form easily. The right end of this die is for DIN. The left end, or end that is now exposed, is for a single or double 45-degree inverted flare. The dies secure the tubing very well. To help keep dies from sticking to the tubing, a lubricant like Miller's red rubber grease can be used and leaves no harmful residue. With the die blocks roughly square in the fixture, move and pin the arm in place. As a first step before flaring, run the screw down lightly. At this point, rotate the turret to operation 0, which is the flat punch that will align the tube and square the die set with the fixture. The tube end should be square with the die set and flush with the face of the dies. Now the arch clamp can be securely tightened. This will assure that the tube does not press through the dies during the flaring process. To reduce friction on the flare punches and the tubing, red rubber grease can be used. This is harmless to rubber, and any residue on the tubing will not damage internal parts in the hydraulic brake cylinders and calipers. Clean brake fluid or Raybestos brake cylinder assembly lube is an alternative. Always avoid the use of petroleum-based grease when working around hydraulic brake systems. Petroleum or mineral products will damage rubber seals. When uncertain about the chemical compatibility of a product, consult the Mikan.com site Rubber and Chemical Compatibility Chart. Miller's red rubber grease will not harm rubber. Never expose rubber brake parts to petroleum fuels, petroleum oil, or petroleum distillates. Here, brake fluid is applied to the flaring punch. This is the second step, where the bubble is formed. The tube is compressed to form the lower half of the 45-degree flare. Always make sure that the turret and flare punch are moving squarely into the die set. Rotate the manual hand lever smoothly with uniform force until there is distinct resistance. Then release the turret from the die and rotate the turret to the second operation, which is the 45-degree cone that will press the convex half of the flare into the inverted seat to produce the double 45-degree inverted flare. The die is 45 degrees inverted. The die punch is a 45-degree match for the inverted 45-degree die. Squeezing the two together forms the double inverted 45-degree flare. You can now remove the die set and tube from the fixture. Tap the die set carefully to relieve tension from the tube. This is an insufficient flare. The flare shoulder is mushroomed. The shoulder is too thick, and the lap is not complete to the bore diameter of the tube. The mini tubing cutter will remove just the flare head, removing a minimal amount of material from the tube. We can form another flare. The mushroom shoulder and the shallow second flare indicate that the tube was collapsing rather than folding where the lap needs to take place. Some causes for this kind of trouble include a tube end that isn't square, a tube end that has too much of a bevel, chamfers that are not sufficient, and lack of grease or some other cause that's preventing the tube end from readily collapsing into the adapter. This time, the major difference is the square end on the tube cut by the mini cutter and far more time spent on the internal and external deburring process. Despite the high quality of the rigid tubing cutter with a stainless steel blade, the blade has quite a bevel on it, which makes it difficult to make the tube end fully square. The die set is square, and this first step punch will push the tube against the die 45-degree inverted angle to form the lower half of the 45-degree inverted double flare. The outwardly curving dome is a convex SAE bubble, or sometimes referred to as a British girdling type flare. Now the second flare punch pushes the dome inward, and the bubble collapses to become the second or double flare seat of the 45-degree inverted flare. The die set and tube removed, the die halves can be separated to reveal the tube. This tube flare looks good. The improved flare seat and flare indicate either the tube end is more square or the tube end was slightly recessed from the die set end. Regarding the tubing cutter and beveled wheel, the closer to a razor shape, the more square the end will be. There is an alternate steel and stainless steel blade available for the rigid 15 SI tubing cutter. We'll try that cutting wheel. Using the correct flare nut is essential. This flare nut has a 45-degree bevel that will match the backside of the new flare. Note that the outer or double flare is concentric and the same size as the inside diameter of the tube. This nicely formed 45-degree inverted flare seat will provide a good seal and uniform flow of brake fluid. The outside diameter of the flare is ideal for this 3/8 24th flare nut used with a 3/16 inch double inverted 45-degree flare. This looks right and will provide a safe and secure joint for a brake connection, or hydraulic brake system PSI ranging from peaks of 2000 to 3000 PSI. There is no room for error, and these joints must seal perfectly. That involves torquing the nut to factory specification to make the inverted 45-degree flare seal tightly against the flare seat of the cylinder or fittings. Considering the professional finish, the elimination of marring above the flare, and general appearance of the flare, this is the biggest bang for the buck in prosumer level brake flare tools.